the figure, B is in position 1. From A to B, it is D13. So IB into Ln 1 by D13. And IC is at position 2. So A to C is D23. Hence Ln IC into Ln D23. Like this, we have framed the equations for the flux linkages in position 1, position 2 and position 3. As shown here. And IA is common in both these terms. So if we take IA is common, and since the denominator there is a 3, you try to just take a 3 common in both the terms. In the first term 3 will get cancelled out. In the second term 1 by 3 ln 1 by d12, d23 and d13. Since 1 by 3, you can write this one as 1 by 3 into ln something. You can write it as ln cube root of, you can write like this. Hence this term can be completely simplified as ln cube root of d12, d23 and d13. Since minus is there, minus 1 by something, so hence we can bring it to upside. It will come to 1 by d12, d23, d13. Now I am taking IA common in both the terms. Again log A and log B is there. Log A plus log B, you can write it as log A B. Hence R dash will come in the denominator. So flux linkages is given by 2 into 10 power minus 7 into IA into ln cube root of d12, d23, d13 by R dash. This cube root of d12, d23 and d13 can be written as d equivalent, that is equivalent distance. And the inductance can be further estimated by using this flux linkages and current. So inductance is given by flux linkages divided by the current flowing through the inductor. So IA will get cancelled out, hence we will get 2 into 10 power minus 7 ln d equivalent by R dash. So where d equivalent is cube root of d12 into d23 into d13. If suppose all the three conductors are placed in a equilateral triangle with a symmetrical spacing, then this becomes d into d into d. Cube root of d becomes d. It becomes important when there is unsymmetrical spacing, then we need to this formula. Now coming to this double circuit transposed line, since when there is a lot of power demand, you need to use this existing lines. So we'll be going for a double circuit line. That is, one side of the tower will have one circuit and another side of the tower will have another circuit. So total 6 conductors will be there in a single tower. Since in a long transmission line, to make the inductance same, we'll be going for a transposition. Therefore, in this particular circuit, we have taken a double circuit with transposed line. You can see on one side, left hand side of this circuit, A, B and C. This is one circuit, single circuit. Another side, C dash, B dash, A dash. For denoting the second line, we have used dash. Since transposition is done, you can see the conductor C dash on the top and A dash in the bottom of the line. Now this will be a real case, especially when the line is 220 kV and above. We'll be going for double circuit lines with transposition. Let us consider the distance between conductor A and B as DAB, B and C as DBC, and the horizontal distance between A and C dash as DAC dash, and B to B dash as DBB dash, and D to C to A dash as DCA dash. It can be sometimes the distance between A to B and B to C will be same, and A to C dash, B to B dash, C to A dash also will be same. Now since double circuit is being involved in this particular circuit, there will be the flux linkage will be due to the current flowing through the conductor. Also the flux linkages will be due to the another conductor, that is mutual flux linkages also will come into picture. Now we'll see how to calculate the flux linkages due to its own conductors, that is due to conductor phase A on one side and another side also phase A will be there, that we are trying to denote it as A dash. So the flux linkage is due to its own conductor, own phase, same phase. The self GMD, that is of the combination of conductor A and conductor A dash, is given by, let us denote it as S. We'll use a letter S to denote it as self GMD, self geometrical distance. For conductor, that is A, we are taking as 1, and conductor B we are taking denoting as 2, and conductor C as a 3, or you can take it as DSA, DSP, DSC. Its notation you can, any notation you can follow. Need not to be 1, 2, 3. Now consider the combination of A and A dash. Now due to its on one side of the conductor A is there, therefore A to A, that is DAA. Also in another side there will be A dash, A dash, A dash, that is the third term you can see. So this is nothing but self GMD, that is given by 0.7788 into radius of the conductor. Now A to A dash and A dash to A both will be same. That is the horizontal distance from A to A dash on the other side of the cross arm, that is the conductor second circuit line. Similarly, the self GMD of the combination B and B dash is given by DBB on one side, DB dash B dash on another side. Now horizontal distance, that is B to B dash to B will be same. Similarly, C dash is given by DS3. Since 4 terms are there, we will get the fourth root of If 3 terms are there, then cube root of. So to follow. Now overall equivalent self GMD of each phase is given by ds cube root of ds1 into ds2 into ds3. And for each phase this ds will be same. Now let us see how to calculate the mutual GMD. Mutual GMD means between conductor of one phase with conductor of another phase. That is, there can be mutual GMD between A to B, B to C and A to C. So we need to consider the distances between A and B. Conductor on one side, conductor A will be there, conductor B will be there. Another side, conductor A dash, conductor B dash. So distance between AB, that is on one side. Next A dash B dash on the second side. Now between A to B dash and A dash to B, it will be same. This will be same. Similarly, mutual GMD between phase B and phase C is given by DBC, B dash C dash, B to C dash and B dash to C. Similarly, between A and C is given by DAC, A dash C dash, A to C dash and A dash to C. The equivalent mutual GMD is given by cube root of B into DBC into DAC. Since 3 terms are involved, it becomes cube root of. Now overall, the inductance of the circuit is given by 2 into 10 power minus 7 ln dm by ds. dm is mutual geometrical distance. ds stands for self geometrical mean distance. Hence, by this way, we can estimate the inductance of a double circuit transposed line. Thank you.